Friends, today we are studying electricity. What you know about electricity? You will say, this tube light, this bulb, this is electricity. I charge my mobile, I run my computer on electricity. But electricity is a very, very wide topic, and so much it is involved in our life that we cannot think life without electricity. You know, if what you see in the clouds, there is a spark, that is electricity. Another wonderful thing, what I see with my eyes, those signals are going to my brain by electricity. My brain is telling my hand to write, and that signal is through electricity. If I write on the board and this black ink sticks with this white board, that is because of electricity. If a pump runs, that is because of electricity. And there are so many features of electricity you can't imagine. It's such a wonderful thing. We are using it in our communication, in mobile, in all other things. So with such a wide topic, when we want to study it, we can't study it in one go, so we have divided into different topics. And the basic cause of electricity, we say the basic root cause is activity of something known as electric charge. This. So this is the root cause of electricity. So first we should have the understanding of electric charge. And I tell you, if you understand electric charge very well, you have mastered electricity. Even if you go to IIT level or any level, everything in electricity is due to certain properties of electric charge, which you will see in next 4 lectures. Okay, so when this electric charge is static at one place, it shows certain effects. All those effects we study in electricity. When this electric charge is in motion, it shows certain different type of effects. Things get heated up, things get lighted up. That we study in current electricity. When this electric charge moves in a coil, it runs our pump, it runs our motor, it runs our fan. That we will study in magnetic effect. Then this electric charge gives many type of induction without touching anything. It is giving effect from a distance. That we will study in electromagnetic induction. Then how we run this electric charge, how we give it energy, that we will study in generation of electricity. And then it gives a wonderful thing of tuning. And this is what we are using in our mobiles, in our communication system. So that all we will study in communication and tuning by electricity. So many things, all these effects are shown by a single thing, that is electric charge. So it is so important. But now we comes to what is electric charge. This is why we need to study electric charge. Okay? Come back to the nature. In our nature, when we study, the nature is made of 2 components. One component is energy, that is in the form of radiations, and other is matter. In our physics, thrust area is reductionism. We want to know the source of this nature, how the things are working, and we want to reach that particular one reason or the one cause which is controlling this universe. So far we could not find it, but we are approaching, making the things, narrow down the things, and we have come to know that this universe is made of 2 things, radiation and matter. And now very recently in modern physics we will study that radiation and matter both are basically one, and that is only and only energy. Sometimes this energy is being shown as radiation and sometimes it is being shown as matter. Okay, both have energy. Now there is one property we will study, that is applying force. In this we will bifurcate, and now we are studying properties of the matter. One very important property of the matter is that it can apply force. When it has energy, it can apply force. Now, what is a force? Force is, in our general language, it is pushing something or pulling something, that is force. Okay. Why a matter should apply a force? This has always been a question with all the physics learners, that why a matter should apply force and what is its characteristic due to which this can apply force, some matter apply force, some matter do not apply force. Does it happen? Answer is yes. We see Earth applies a very large force. If I leave this, it will go towards Earth, and here I call it come back. It doesn't come back. Why it does not come back when this hand is ordering it, and why it goes towards Earth? So we find a reason. We find the reason that Earth has got larger mass than my hand. So there is a force due to mass. We have given it a name, and that name is gravitation. That is force of gravity or force of gravitation. And the reason for force of gravitation is mass. Now, in our nature, we declare, yes, now we understand the reason of force is mass. Anything which has got mass will apply force, and Earth is the largest body in our nature around us which will apply force. Okay, so Earth will attract the things towards it. But then I see some different forces. A matter is applying the forces. These are few pieces of paper. This is my pen, this pen. This requesting the papers to come. They do not come. It has no power. Okay, now I rub it. And now I put it here. See. Now gravity is calling these down, but this has attracted these pieces of paper against the gravity. That means this has got a very large force which is larger than the gravity. Now I am surprised. All physicians are surprised that in our nature there is another force which is larger than gravity, and it can act against the gravity, and it can also attract. So we should give a name to that force. Normally in physics we don't like to make many topics. We want to limit them to one. So far there was gravity, one force, but now this second force has come. We cannot explain it because of mass, because this pen has got a very small mass compared to Earth. Why it should attract the papers upward? No answer. No answer. So we have to establish something new, that this nature has got more than one type of forces, and this other type of force which is attracting, we will give it another name, and we give this name electrical force. Why it is electrical force? I will tell you. That story will also come up. Electrical force. Now this gravitational force is because of the property mass what anything is having. What is this electrical force is due to which property? We know it is not due to mass, because this mass was less and it was attracting. So what does it has? We have to give that property a name. We have to give that characteristic a name which is pulling it up with the electrical force. So we want that name, and it was very easy to find a name. First, when I put this pen here, it is not attracting it. When I put this pen after rubbing, it is attracting it. So I say now this pen is charged. Charged means what? Having force. When an army goes to attack, what the general shouts? Charge. That means attack, have a force. So having a force, for that a very common word is charge. So we call it is charge. What does it show? Electric force. So we give it the name electric charge. So this is, we have to, there was no alternative, we have to create another force, we have to find out another property of the matter. That matter has got two properties, one is mass, due to which it applies the force of gravitation. Another property is electric charge, due to which it applies the electrical force. There is no third force so far we could find in our nature. Macroscopic, microscopic, inside the atom we do have. We call them nuclear force, strong nuclear, light nuclear. When we go to nucleus we will study that. But macroscopic, what we see with the eyes, what we experience, these are the two forces, and so this is electric charge is the root cause of electric force. So now can we define it in the words? Okay, we can define it very well in the words. So now we can write definition. Electric charge is characteristic developed on a matter due to which it can apply force on other particle. So remember two things. One is this has to be a matter, and on that matter this characteristic is developed, electrical charge. So matter is compulsory for electric charge, and the one thing you must remember for electric charge is the basic condition for electric charge is that charge is carried by material. If somebody asks me what is the most important feature for electric charge, I will say this is the most important feature. If there is no material, no charge. If I give it a charge, some material has come to it or has gone from it which is having charge, and that is carrying charge. Now another thing we discuss in the charge is the property of cling. Electrostatic cling. What is this electrostatic cling? This is what we have discussed earlier. This ink is having a electrostatic cling with the whiteboard. This we observe at many places. Okay, the clothes we wear, they stick to our body because of electrical cling. That is electrostatic cling. Two things just closing to each other, attracted to each other, that is electrostatic cling, and that is because of the electric charge developed in them. Now another thing we wish to study is how do we produce electricity. The basic thing for producing electricity, now I will say the one method is rubbing. Rubbing, create electrical charge. Okay, you can make notes of it. Rubbing creates electrical charge, and when we rub it, it has got a power to attract, it has got electric charge, and what we have done, in one word, we will say that we have electrified this. Electrified. So we use the word electrification. What is meant by electrification? Charging a body. That means giving certain charge to a body. So when I rub it, I have given it some charge. What I have done electrification of this body. So we will use word electrification for this purpose. Now this electric charges, the particle which have got electric charges here, they will stay here, and because of this, earlier it was not charged, now it is charged, it is showing certain effects to me. All those effects we will study in a branch of electricity, and that branch will be known as electrostatics. So electrostatics, branch of electricity in which we study the effect of static charge, the charge which is not moving. Okay, so this is electrostatics. Now, another word we normally hear is about what is frictional electricity. So you see here, when we do the rubbing, it gets charged. But if I do this rubbing maybe with polythene, it may not create charge. Here it may not create charge. Why? There is no friction between the two. Friction means this surface should be rough, this surface should be rough, and when we rub it, some particle of this either should go here or some particle of this should go here. That particle will carry electric charge. So friction has to be there, and because this electrification is due to friction, we also call it frictional electricity. So electrostatic is also sometimes referred as frictional electricity. Okay, then these are certain features of the electricity. Now, electric charge, there was very wonderful thing about electric charge which compelled us, which had given us certain questions. You can also think about those questions, and that is what Benjamin Franklin thought it first. So it will be a mind twister for you. Think that what does electrical charges do? Answer, they apply force. Okay, what type of force? We have seen they attract. Okay, if they attract, fine. We have done certain experiments. So electric charge attracts. What we did, we took a glass rod, rubbed it, it got charged. What is the proof? It was attracting the papers. Okay, so we had glass, and this is charged, it can attract the papers. Now we have another plastic piece, plastic rod, and we rub it, it is also pulling the papers. We say it is charged, plastic. Okay, this is charged, this is also charged. Now we hang them with help of thread and bring them close to each other. These two, we bring them close to each other. Now what do we expect? The answer, both are charged, they will attract each other and they go like this. We see it happened, and they go like this. There is a force of attraction between the two. So far so good. What we have declared, electric charge attract. Okay, this is the property of the electric charge body. Now what happens, there is a glass and there is another glass tube, both are charged, and we bring them close to each other by hanging them, and what we find that they repel each other, glass and glass. And what are they doing? Repel. They repel each other. This is a charged body, this is a charged body. So charged bodies do, what do they do? Attract or repel? You can also think, both are charged bodies. Now what is the nature of electrical charge body? It is attraction or it is repulsion. And that was the problem with studying people, that physicists, whether the charge they have discovered, whether it is a attractive property or it is a repulsive property, and there was no answer. They studied where do they attract and where do they repel, and now you also know that you can very well make it from the beginning. We are writing it, glass to glass repel, glass to plastic attract. But how we can explain that? How we can explain that these two charged bodies, this was attracting the papers, this was also attracting the papers, both are having electric charge, why they should attract and why these should repel? Both are having electric charge. One electric charge cannot express two type of characteristics. How we can explain that when it will attract and when it will repel? Okay, then there was no other go, and when there is no other answer, we have to create something new. That this also happens. Like when there was a force of gravity and the paper was attracted up, we had no explanation. So we said there is another force. Here, these two are attracting each other, but these two are repelling each other. So we have to say there are two types of charges. Only one type of charge should show one type of property, but they are showing two types of properties, then there have to be two types of charges. So we decided two types of charges. And preliminary we said one type of those charges which are created in glass, and one are those type which are created in plastic rubbing. Okay, they are the representative of two types. And then we made a rule that similar charges repel. In this case, glass repel. If they are plastic, then they will also repel. But if they are glass plastic, they will attract. So similar charges repel and opposite charges or dissimilar charges attract. So this is rule made which will satisfy these two phenomena. You see, in our scientific method, we have studied anything, that any rule we make, any law we make, this should be able to satisfy and explain whatever happening in the nature. In our lab, these two things are happening. So we should make a rule, we should make a law which should explain both these things. And this statement that there are two types of charges, if they are similar, they will repel, and if they are dissimilar and opposite, they will attract. This holds good. Now, if there are two types of charges, we have to give them names. And this name was suggested by Benjamin Franklin, and he said that these two charges, we will give them name plus and minus. That is positive charge and negative charge. This was a very strange name. So far, people were putting the names either due to their properties, that is oxygen, hydrogen, nitrogen, or due to the scientist like Faraday, Newton, and all these things were used as a name in physics. But here, what he has given the name he has given is positive and negative. What strange type of name, why this was given? This is a question which is not generally asked, but in very peculiar examinations, this may be asked. And you may also be interested to know why these were given. The reason is very simple, you will also agree. When we add hydrogen to oxygen, we get something new, that is water, H2O. Similarly, whenever you add two things, they are not destroyed, you get something else new. That is for everything else. But for electric charges, what happens? And another thing, yes, I want to tell you what happens in mathematics. Add two things. One is plus 3, one is minus 3. Add them, what you get? 0. Nothing. Neither this remain nor this remain. So in mathematics we have a phenomena when two things are added and both vanish. Nothing happens. The same thing we have seen in the charges. How? We take charge on the glass we take charge on the plastic, both are lifting the papers, both are powerful, both are charged. Now we touch them. If we touch them like this, and after that we again separate them, and now after separation I put papers here. Now these are not attracted. So we say charge is gone and this charge has become 0. Now where is the charge this, where is the charge this, where it has gone? We don't know, that we will discuss later, but one thing is there, they have become 0. So which type of addition property they have shown? Is it the property of chemical things where hydrogen oxygen makes a new thing, or it is a property shown by mathematical numbers which when added together become 0? So the answer is it has shown the property of mathematical numbers, because practically they also become 0. So which will be the appropriate nomenclature? Should we give them name like chemical names of material, or should we give them mathematical names which are positive numbers, negative number? So the more appropriate method is if we give them mathematical signs, plus and minus, because when we add them they follow mathematical rules. That is why their names were given as positive and negative. So we will write why the two names were given to them. Okay, so we have written the same thing what I explained you, that charges were given positive and negative names because on addition they give 0 result, which is property of mathematical numbers having sign positive and negative. So names were given positive and negative, which is more appropriate. So this is the reason why this strange name positive and negative were given. We will study few more properties of the charges. The first, if I am rubbing this material and this is getting charged, there is a quantity of charge. In physics, every physical quantity can be measured. So there will be a measurement of this charge. This charge may be initially less or more. Then how much charge can be created on this material? The answer is very, very large charge can be created. So there is no limit, and I will write it this way: very large charge can be created on a body. Okay. The charges are positive and negative, two types. When we develop by rubbing positive charge or negative charge, then both the charges are created in equal quantity. So while creating a charge, we cannot create a single charge. We have to create charges in pairs. We have to create charges in pairs equal, positive and negative. Positive and negative both will be equal. If I am rubbing it with my coat and creating charges here, if these are positive charges and its quantity is 1000, then definitely 1000 negative charges are created on this cloth. It cannot happen that I will create here 1000 and here it is no charge or it is 500 charge. It has to be opposite and it has to be equal in numbers. This is a must. Now we are talking about positive charges, negative charges, different charges. Practically, where do we get these charges? So these experiments were done by Faraday, and he gave that which material will carry positive charge and which material will get a negative charge. He did many experiments. How do we get it started? So first thing, when we rub a glass and it gets charged, we say arbitrary, we decided that this charge we will say positive charge. So what represents a positive charge? The charge on a glass rod. Similarly, negative charge is represented by a charge when a plastic rod is rubbed. Okay, what about the other things? So he rubbed many things. Anything which is repelling glass is positive, and anything which is attracting plastic charge is positive. Anything which is repelling plastic charge is negative. Okay, so with help of this principle, he made a series which he called Faraday's series or electrostatic series by Faraday. In this series of material, he put a few day-to-day use material, and in this there is a rule that whenever any two objects of the series are rubbed together, the one which is higher in the series will get positive charge and the one which is lower in series will get the negative charge. This will help us just as a fast index for you to find out whenever we rub two things, then which one will get which charge. Like if I ask you that I have a silk hanky, with that silk I am rubbing glass, then what is the charge on silk? You see here glass and silk. So glass will get positive and silk will get negative charge. It is higher on the series. Okay, now I take another sample of silk and rub it with plastic. Plastic is where? This resin. Resin means plastic. If I rub with plastic, then plastic is lower and silk is higher. So silk and plastic when rubbed together, in that case silk will become positive and resin will become negative. So on silk, if I ask you on silk, which charge is developed when we rub it? You cannot reply whether it is negative or positive unless you know it is rubbed with what. If silk is rubbed with glass, it becomes negative. If it is rubbed with plastic, it becomes positive. So this is just a reference point. At that time it was used a lot, and this gives us a representation. On top of the list, glass. Glass rubbed with anything will always become positive, and sulfur we don't use practically much. So resin or plastic rubbed with anything will always become negative. So these are the two representative of different charges. Now another thing I wanted to discuss is, now once we know positive and negative, we had gone for a term that was electrification. What is meant by electrification? Giving charge to a body is electrification. Okay, we have given charge to this body, positive charge. We have given charge to this body as negative charge. When we touch the two, and then again separate it, and now we find that both charges have converted to zero. This process, when we touch thing, something happens, the charges nullify each other, and this we call discharge. This is charge and these are discharged bodies. So the vanishing act of the charges is discharge. How it has happened? What we have seen, if we bring these two bodies, highly charged bodies, very close to each other, practically when we bring them very close to each other, even without touching, we see a spark here, this spark, and after seeing the spark we see that both have become zero charge and their charge has become zero. We say the bodies are discharged, and normally practically this spark we give the name as discharge, because after this these bodies get discharged. So spark has become mononymous with discharge of electricity. And this we see all around us, like in stones, in many other things. When we rub it, there is a discharge. So the example of spark, very big spark, is lightning in the sky, lightning in the clouds. And right from initial days of science, it was a big question with the scientist, what is this lightning in the cloud which we see shining? And with this advancement of our knowledge, for the first time the physicist said that this is this spark of electric discharge, what we see in the clouds. This was a very vague statement because nobody has gone to the cloud and seen whether this electric discharge is there, what we are seeing on the earth. But Benjamin Franklin said no, it is the same, and he did his very famous kite experiment. Kite and cloud experiment. And in this, he just raised a kite up to the level of the clouds just to see whether there are charges. How we will see there are charges? Before that, there was one activity, and that activity we should understand that if there is a charged body, how we will come to know that it is a charged body? So answer is very simple. Put your finger in the plug and you will come to know what is a charged body. Okay, it gives you a shock. So giving shock is, and after that, that body gets discharged. This shock we receive, modern days we get it from this electricity, but in earlier days also, if you get a very large container of copper, rub it, keep on rubbing it, it will collect a lot of charge. And after that, if you touch it, you will get a shock. Okay, we have such things even now in physics. When you go to BSc or the higher classes, you will see those generators, electrostatic generator, and they give very severe shocks. Okay, so shock was our significance that this body is charged. So he sent that kite to the sky, to the clouds, thinking that there will be a shock in the thread, but he did not get it. So he could not prove. Then he said maybe that thread is the culprit or the kite is the culprit. So he put a key, a metal key, and he tied it with the kite. With the kite he, yes, here he put a metal key. That metal key will send the charge. But again, he could not see any charge here. Okay, he was disappointed, and by the time he was removing his kite down, at that time the rain started. And when it was raining, suddenly he got the shock here. And he was the first man after getting the shock who has become very happy. In place of shock, he was very happy that yes, there is electricity in the cloud. And this was a marked achievement, telling that whatever spark we are seeing in the clouds, that is basically the same electric charge what we are doing here in glass and plastic when we touch them. So that was the first time it was proved that that is the electricity, and we call them electricity in the sky or whatever studies we made it. There were many studies which were made with that. So that is discharge, and this is all about electric discharge. So this we have studied now, what is meant by charge, what is meant by electric discharge, and how the bodies get positive and negative charges. So now in the next class, we will switch it. So far, what we were studying, those were very old days, and by that time, atom structure was not made. When all these things were happening on the parallel front, there were other scientists who were doing the experiments with the material, that a small material is known as molecule. The molecules are many types, hundreds of thousands of types, but all those molecules are made with hardly 100 atoms. All these different combinations make the molecules like H2O, H2O2, CO2, CH4, but all these using 100 atoms. Now, there were more experiments going on that all the atoms are different or they similar, and there were results that all atoms are made by only 3 types of particles, or they have only 2 components. One is nucleus and one is electron moving around it. Now, the people were studying the properties of nucleus and electron, and there they found a strange thing, that all electrons are carrying negative charge. And the electron is something which they could not break. Till date, they could not break. And that is the smallest particle which was carrying electric charge, and that was responsible for electric charge. What we are telling again and again, that matter carries electric charge. They found the matter, and that matter is electron. And that gives clarification of everything which we have studied so far, and they made a new theory known as electron theory of electrification. And that gives us the modern theory of electricity which we study nowadays. So, from there our actual study of electricity will start from electron theory. Okay, we have done electron theory, and what we have studied, that whenever we make a body negatively charged, there will be certain excess of electrons falling on it. Now, electron is a material which carries the charge. We know that there is no other method to give negative charge to a body except an electron goes and sits over it. There is no other method to make it negatively charged. Now, if we want to make it negatively charged and an electron goes here, electron is a particle, particle has a mass. So, that means that mass also sits on this. That means the mass is increased. We want to give it only charge, but it is a binding with us that we bring an electron which will bring mass with it also. So, we cannot create a body negatively charged unless its mass is also increased. So, this is the relation, that a negatively charged body will always get some mass as well. So, we made a rule, from 0 to minus charge, electrons are added, therefore mass will always increase. The similar thing, how do I make it positive? A glass rod I rub. According to electron theory, it will leave some electrons with the cloth and this will become positively charged. Now, if this has left some electrons here, then its mass will decrease. So, every positively charged body has left certain electrons which have gone out. So, definitely its mass has decreased. Remember, when we give a charge, what is the language we are using? Mind it. We are giving positive charge to this body. What will happen to its mass? You are always tempted to say, if we are giving something, the mass will increase. But no, it is a misnomer. We give it positive charge. What is happening to electrons? The electrons are going out, and that means the mass has decreased. So, we use the word give for the positive charge, but in fact we are taking out electrons. Therefore, its mass will decrease, and we noted, okay, 0 to positive charge change in any body. For that, electron leaves and its mass will decrease. So, these two principles you will remember. Now, for your reference, how much? Answer, electron, one electron has the mass 9.1 into 10 to the power minus 31 kg. So, whatever is the number of electrons leaving, we can always calculate mass with this. Okay. So, this is charge mass relation. Classification of material, how we classify material with reference to electric charges. Motion. Motion means what? If I rub this plastic, and lift the papers, it will do because it is charged. If I rub a metal plate, copper, silver, then I see that it is not lifted because answer, it is not charged. But I am sure it is charged. Why I am sure? Because when I rub it and I check this is negatively charged. That means there was an equal positive charge on this. Then why it is not showing the charge? The answer is that charge has gone to my body and it has gone to earth. Okay, it should happen every time. Now when I do it with the plastic, it gets charged and now it is not going to earth, it is showing its force everywhere. Why it has not gone in case of plastic and why it has gone in case of copper? The answer is, okay, we don't have a single answer, and when we don't have a single answer, we classify. Few things behave like this, few things behave like this. The same thing we have done for the material, and we classify the material. There is one class of material which allows charges to move, copper, silver. There is another class of material which do not allow that to move, that is glass, plastic. You rub it, this particle will get, the charges will accumulate here and these charges will not move. So we classify into two types. One which allow the charges to be conducted. So we call them conductors. Conductors. And other is, we will call them insulators. Insulator, which will insulate the charge here, insulate, separated out. So, which will insulate the charge on this part from this part. So, those are known as insulators. So, conductors, I will write the definition of the two. Insulators, all such material which do not allow electrons or charged particles to move freely within them are insulator. Example, plastics, porcelain. Okay, now this property of conductors which allows charges to move makes them conductor. We need it whenever we want to carry charges from one place to the other place. We need a conductor. Like the powerhouse is generating electricity and I need to move charges from powerhouse to my house. So what do I need? I need a conductor. Now I want that all those charges pressed by powerhouse should come to my house, but such a long wire I have to rest on the poles. Whenever this wire is going to the pole, the charges will come here and will go to earth. I want them not to go to earth, I want them to come to my house. So, what can I do to avoid that they should not go to earth? The answer is, when there is a conductor coming to my house, in between conductor and this pole, I will put an insulator. What it will do? It will not allow charges to move to this, and this is what you see. On the poles, just see it minutely. Always you will find that the wire is not connected to pole and there is always a porcelain between them. That is why we save charges to move. Simply, again, we do not want charges to move through our body because that will destroy our nervous system, which is also an electrical system. So, charges should not come to our hand. So, what we should do? On every conductor, we put an insulator. On every machine, we put an insulator so that we can hold it. Now, the charges will not go to my body and to the earth. So, both are equally necessary. Like in your motorcycle, if you have an engine to run it, that is a must. But the very next thing which is a must is a brake. If you don't have a brake, you won't even dare to run a motorcycle. So, this is conductor for conducting electricity, and this is insulator to hold it so that it does not go to any unwanted place. Okay. Now, a conductor has a property, good conductor, very good conductor. What is that property we call? So, we call that property as conductivity. And what is property of insulator? Insulator, we have a property that insulation, or we call it dielectric strength. Dielectric strength. Okay, so remember, what is property of a conductor? That it is a good, a better and the best conductor. That property is conductivity, which is more and more. And for insulator, it will not allow, it will dielectric strength. It will hold the charges to move, and that strength for holding is the strength of a insulator. More is dielectric strength, better insulator it is. More is conductivity, better conductor it is. So, after conductor and insulator, we did certain more research, checked up each and every element, each and every compound, and we find there is another class of compound which is sometimes conductor and sometimes insulator. How it happens? There is a certain class which has examples of silicon and germanium to lead with, and there are so many compounds. These are such compounds that when they are cold, they are insulators, and when they are hot at a higher temperature, they become conductors. And such material is known as semiconductors. And this is semiconductor, it has become so prominent, so important, that this is the thing which we are using in all our electronics. Whether it is computer, whether it is calculator, our mobiles, everything is made by semiconductors. So, as such, we have put it a different class into it. So, now we have three classes, conductor, insulator and semiconductor. There is a fourth class which is coming up, but it is still under a lot of studies, and that is known as superconductors. So, when we go to the topic of current electricity, we will study it in that, but now you can only remember superconductor is a conductor which is super. It does not resist at all any current. So, that is superconductor. We have done insulators, saying that insulator do not allow charge to move. The answer is we must know the mechanism of movement of the charges. An insulator, okay, there is a nucleus here and there are electrons here. The normal process of moving an electron from one atom to the other atom, that this electron will leave it and go to the next atom, then one electron will leave it, go to the next atom, this will leave and go to the next atom. So, what we will see, the charge is getting conducted this way. Now, suppose this refuse, that I will not leave this electron. Why it will refuse? The force between this positive and this negative is very strong, and whatever attraction we do by many positively charged particles here, this is positively charged particles, all of them are attracting this negatively charged particle, but it does not go. Why it does not go? The force of attraction by this positive is very strong. So strong that they do not go here. How much strong? Okay. They go on increasing their force. The force is increased. The force is increased. Now it has become 1000. We increase it more. The force has become 1 lakh Newton. So much force is there. It does not go. Now we again add it and make it, suppose we made it 10,000. unit of the force, this does not go because this force was very strong. Now we make it 10,001. Now this force is so strong, it is stronger than this, and this will move. The moment it moves, it goes to this goes to this goes to this, it becomes a conductor. So this was, now we can ask a question whether it is an insulator or it is a conductor. We will say up to this much it was insulator, but when we apply this much force on it, it has become a conductor. So in this you have to understand few terms. One is, it has not allowed the charge to move up to this much force. So this is the force up to which it will remain an insulator and it will not allow charge to move. Therefore, this is known as dielectric strength. This is strength, dielectric, to oppose the electric force. So this is the strength to oppose the electric force. This force will make it, will do a breaking of this and will make it conductor. So this we call breakdown point, or this is breakdown field. For the force we will use the word here field, because the force which is applied from a distance without touching. There are two types of forces. One is the contact force, put a contact, apply force. Other is field force. Leave a ball here, earth will pull it down and earth is not coming in contact. Without coming in contact, earth is pulling it. That is field force. So electric charges are also applying field force. Now there is why we use the word field for the force, and this 10,001 is known as breakdown field. So this is the maximum strength which up to which it will remain an insulator, will not allow charge to move, and this is the breakdown field when it will this will break down and this insulator will become a conductor. So these two things are very important and you have to understand. Now we can express in words, and I can write the definition for this. Dielectric strength of an insulator is the maximum strength of field it can withstand without becoming a conductor, that is allowing charge to pass. So that maximum strength is known as dielectric strength. Okay. Now the breakdown field. See the breakdown field. The breakdown field is the minimum field around an insulator. Minimum field around an insulator required to conduct charge through it, that is break down its insulation. So the minimum field required to break down its insulation is breakdown field. So these are the two terms, dielectric strength of insulator and breakdown field for an insulator. Now we are doing a very important topic, that is electrostatic induction. I want to understand one or two things beforehand. Number one, we take any material, it has got negative charges as well as positive charges. These negative and positive charges, how does it acquire? Okay, we have learned that in the atom the net charge is 0. In the atom, whatever are the charges at nucleus, the same numbers are there for electrons, and we find the net charge is 0 and electrons are moving around it, and this material as a whole has 0 charge. Then does this material has charge? No. If I want to put a charge, then from where do I get it? There is no charge. All atoms are 0 charge. So I want to tell you one thing, that this situation is when the temperature of a body is 0. And what 0? Kelvin. And how much is 0 Kelvin? Minus 273 degree Celsius. If it is such a cold temperature, these are having energy. With that energy, only that much energy that it can rotate. If energy is more than that, then what will happen? If energy is more than that, then when they are rotating around this and energy increases, they go like this and they go out. Once this electron goes out at high temperature is what? Room temperature, because room temperature is how much? Let us say 27 Celsius. 27 degrees Celsius is plus 300 Kelvin. So from 0 Kelvin to 300 Kelvin is lot of increase in the temperature. If this is increase in the temperature, then there is lot of energy given to this electron, and maybe some electrons will leave the orbit work and will go out. Now when they go out, we get, in place of one box, we get two boxes, two particles. This particle has got one electron less, so this we will give positive charge particle, and this electron is another entity, this is negatively charged particle. So now in this body we have one positive charge particle, one negatively charged particle. Basically they are produced by an atom which was having 0 charge. So how much is net charge of a material? Answer: net charge of a material is still 0. But in this there are few particles which are positively charged and there are few particles which are negatively charged. So in any body it happens, this number may be more, less, very less, but there are certainly certain negative charges and certain positive charges. This is the condition mostly for metals. For insulators we can say that this does not happen, but for metal this is happening, and we get lot many positive charges, lot many negative particles separated, move around. But these negative particles cannot come out of this surface, because moment they go out, rest of the material will become positive and it will attract it back immediately. So now we have this one body, it has got lot many positively charged particles and many negatively charged particles. How many? Answer is equal in numbers, because the net charge of this is 0. But even the net charge is 0, there are separate particles, positive and negative, that I have explained you, which are formed at the higher temperature. Okay. All these electrons, negatively charged, keep on moving here and there, and they are spending time here, 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 everywhere. They are spending time. Now, I do one operation. I charge a glass, and that glass rod I keep here. This glass rod has got certain excess positive charges. What is excess positive charges? Now you know. It has lost certain electrons, so the number of positive charges are more, so it has got more positive charges. Let us say we are not showing the neutral atoms, we are not showing the electrons, we are showing only excess charges, which are positive charges in this case. Okay, this is positively charged. It has got all type of charges, and all these charges are distributed all over the material. The moment we put it close, all these positive charges, according to their nature, attract negative charges, and according to their nature they will repel similar charges which are positive charges. So positive charges are repelled, negative charges are attracted. And what we see, all these electrons are moving very rapidly here and there. They are spending their time all over. But suddenly we find many of the electrons, majority of the electrons spend their more time in this corner. And more of the positive charges spend their time on this corner. Why? The positive repel positive and the positive attract negative, and now we find it this way. This is our positive glass which has got excess of positive charges, and what we find here, plus, minus, plus, minus, plus, minus, all these are there, but in this one corner negative, and in this one corner there are positive charges excess. So this is what we have all around. Not effect on all the charges, but electron, that is negative charges, try to spend their more time on this corner, and positive charges try to spend their time on this corner because of this repulsion on positive. This is repulsion and this is attraction. So this is what happens. Now we can say that these were the charges mixed, positive, negative here, like this. Once we have put this positive here, what has happened? All these plus, minus, and they were like this. Now the moment we put this positive, and they become like this. These are negative charges, these are positive charges, rest are there. So negative go to one corner, positive go to one corner. In general language, what do we call this phenomena? We call this phenomena polarization. Polarization, the particles of different nature going to different corners. Like in our class we say boys will sit on one side, girls on one side. So there is a polarization. You want a holiday on Thursday or Friday. Half of the people say Thursday, half of them say Friday. So our thought is, our decision is polarized. So whenever there is a separation, there is polarization. Now here there is polarization of charges, electrical charges. Why it has happened? Because there is a charged material which is brought near to an uncharged material. Yes. It was like this. When we bring it here, then they get polarized. When the charges get polarized, this incidence, we call it electrical or electrostatic induction. Electrostatic induction. So, is there any touch between them? No. It has applied the force without touching. Whenever we do a job without touching something, then we have done induction. Remember the word induction. Induction is doing a job without touching. Without touching or without making a contact. Then we say induction. Okay. So the charges are brought to one side without touching them. So this is electrostatic induction. We can write one line definition of it. Okay, this is electrostatic induction. When a charged body is brought near an uncharged conductor, the free charges in the conductor gets polarized. This phenomena is electrostatic induction. What is the result of this electrostatic induction? Now you see this positive, this is negative, there is a force of attraction. This positive and this positive, there is a force of repulsion. Now, can you tell me what will happen to this body? Will it get attracted towards this or will it get repelled by it? The charges are equal. Yes. The answer is it will get attracted. Why it will get attracted while the charges are same? The answer is the force of attraction is between these two charges and this distance is less. So the force is very large and this distance is large. So the force of repulsion is smaller. Therefore, attraction force is larger, this will get attracted. Okay, was this body a charged body? No, this is an uncharged body. So this is a charged body. Now there is a basic fundamental question. Can a charged body apply a force on uncharged body? There are two answers, yes and no. Yes, because this is an uncharged body, it has attracted it. This you have seen when I show you the pieces of paper which were uncharged. This I made charge, put it here, it was attracted. So uncharged body, so charged body can apply force on every body, even if it is uncharged body, it can apply. But if you go very minutely, why it has applied force on it? Because this portion, this one body has become a charged body. So it has applied force of attraction. This body has become a charged body. So it has applied a force of repulsion. But this force being stronger, the net result was attraction. So basically there is a force between charge to charge. It so happened that these two charges are in the same body and we say it is a neutral body. So in our general language, we remember, in a neutral body, when we bring a charged body to it, two things happen simultaneously. Number one, this is what? Induction. And just after induction, we say there is a attraction, because this force is stronger. So we have a very famous sentence in electrostatics that there is always an induction before attraction, because if these negative charges are not here and plus are not away, then these two forces will be equal. Why these forces of attraction are more? Because they are closer, because there had been an induction earlier. So induction precedes attraction. So whenever you are attracted, first there has to be induction, then only there will be attraction. Remember that. Okay? So this is what happens whenever there is a attraction. Attraction cannot happen without induction. Okay? So next class we will study that how we charge a body, what are the different methods, and there are very interesting methods, 2 or 3 methods, we will study that. How do we charge a body? I have a conductor and I want to charge it. It has got charge. If somebody asks you, there is a conductor or a body, does it have a charge? Our answer is always yes, it has a charge. And now we will make two terms very clear. One is having charge, only charge, and one is having net charge. And these two are different. It has got 1000 protons and 1000 electrons. So we cannot say it's not having charge. It is having charge equal to 2000. 1000 positive charges and 1000 negative charges. Yes. But if you make total of it, it is 0. So its net charge is 0. And its charge is 1000 plus 1000 minus. So but net charge is 0. Now a body applies force because of net charge and not because of charge. So if there is a net charge, the body is able to apply force. If I want this body to be charged, so in our general language, what we say that we want to charge a body, to charge, that means to create net charge. To create net charge. And how do we create a net charge? Either increasing or decreasing the number of electrons according to electron theory. Okay, so that we have to do in this, and for this we have two methods. One method is method of conduction and another is method of induction. So this is charging a material by conduction. This is uncharged material. When I say uncharged material, then no material can be uncharged. When I say uncharged, that means plus and minus are equal. 1, 2, 3, 4, 1, 2, 3, 4, yes, like this. So this is net charge 0 and I will say it is uncharged. I want to make it charged. The first thing I do, I bring another material, say I have a plastic, I rub it, bring it closer to it and touch it. This. And this has got negative charges. Now what happens that when I do touch, when there is a process of contact, there is a process of touch, then what happens? Some electrons or the negative charges will come here. And these number of electrons or negative charges will become larger. The number will increase. Now, can you tell me why these electron or negative charges should jump here? If they are living here peacefully, why they should go here at all? Who is pushing them? Answer is they themselves are pushing, because we know similar charges repel each other. So all these charges repel. It is repelling this, these two are repelling this, all these three are repelling this, and all these charges are repelling the last one. So last one has no go. If it comes in contact, then it will go here. Here once again I tell you another thing. This is a body, it has got excess negative charges and the negative charges are repelling each other because they are similar in nature. So where do they go? Answer is they all go to the surface. Yes, it's a very important question that in a conductor which is negatively charged, where are the charges located? The answer is charges are always located on the surface. Charges are always located at surface. Why? And the very fundamental reason which you learnt in the first topic, that similar charges repel each other. If they repel each other, they move, and this is a conductor. If this is a conductor, this will allow these two charges to move. They repel each other, it will move here and this will move here. Yes. So all the charges will move up to the border. Why don't they go out? Even now they are repelling each other. If it wants to go out, outside there is air atom. And air atom is an insulator. It is not possible for this electron to move into this air because this is an insulator. This will not allow. So it has to stay inside the conductor, but inside the conductor it has to stay on the surface. So remember this, a very fundamental thumb rule. In a conductor, the excess charge always stay on the surface. It does not go out because outside air is an insulator. But still they are repelling each other, and if they find a place to go, they will go. Here they find a place to go because I have made a contact and touch with a conductor. Now there is no air and there is a conductor. These electrons are repelling this one, and this can go here because this is conductor, this is conductor. The passage is allowed. They go here. Now all these 9 repel the 10th one, it goes here. Now here are 9, here is 1. Now 8 will repel the 9th one, that will go here. Now this 6 will repel the 7th, that will go here. So by this method all electrons are going here, but after that sometime what happens, if here are 5 remaining and 5 have gone here, now when they are sending the 5th here, all these 5 repel it back. Now the force is equal from this side and from this side, and they will stop going. But before they stop, there has been certain distribution. Out of 10 electrons, 5 are already repelled to this conductor, and now this has an excess of 5. Earlier it was 0, now it has an excess of 5. So what is its charge? -5. And after that we remove it. When we remove it, we find here that this was 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6. This was the earlier case, 5 have come here. Now it has got excess of electrons, and we say this body is now charged, and this charge has taken place by contact, by touching. So this one method is conduction. So for conduction, what is the requirement? A charged body and a contact. This is charging by conduction. Now we will study how we can charge a body by using the process of induction. Suppose we have a conductor, and this conductor is having no net charge. When we say no net charge, I need not to repeat that it is having lot many charges, but the net charge is 0. Equal number of positive and negative charges will make it 0 charge. Okay. Now I want that it should develop certain net charge. For that, what do? I bring a charged body near it at certain distance. Okay. This is a, say, negatively charged body. If it is a negatively charged body, induction will take place, and in the induction what we see that positive charges come here and negative charges are repelled on this side, and plus minus both are here like this. Okay, so this is induction has taken place. Now as a third step, this I connect it with the earth. This is symbol of earth. What happens when we connect a body to the earth? The answer is, this is a conductor, and earth is such a big large body that this can also be taken as a conductor. Now if this side are excess of electrons, these are being repelled, they want to move away. They were not able to move away because here is air which is insulator. But now I have connected it with a conductor. They have a passage to move. Conductor, and this goes to earth, and earth is a very large body which is also conductor. So what happens when they are repelled? They go from here. They move to earth. This is earth, means a very large body, and these positive remain here. They don't move from their place, and all these are there as it is. So these are now moving here and these are gone. It has become like this. These positive charges and these negative charges, there is an adjective we use for them. These are attracted by this minus, by this, and whatever is happening with these charges, they will not participate, they will not move from their place. So we give them the name bound charges. Bound charges. They will not participate in any activity of the other charges because they are bound charges. They are spellbound by these negative charges. They will not move. And these are known as free charges. If they are given a path, they are given a way to move, they would like to move. But air is an insulator, it does not allow them to come out even if they are being repelled. So they remain here. Now we have given them a conducting path to the earth, and because it's a conductor path, all minus will flow through it, go to the earth. But these do not move, these all remain here. Okay. This is second step. In third step, what we do, we cut this path. If we cut this path, then these charges are there and these charges are there, and still these are being attracted. Next, we remove this. When we remove this, what we find that this body is now 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And they keep on moving. But is it now a neutral body or a charged body? Answer, there are excess positive charges. So this is now a charged body. And when we started, how it was? Uncharged. Why it was uncharged body? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Equal uncharged. How much was the charge? 0. Now it is a charged body and the charge is, yes, it has come from here. Okay, now in this process, what you see, have we touched it with this conductor? We have taken help of this, but it is not touched. Not touch, no touch, no contact. So what it has done? It has done only induction, but this body is charged. So we say that this is charging of a body by induction. This is how we charge a body with induction. So practically what we do, I put it like this, bring it near another body, say this is a conductor. I rub it like this and put it like this. That's all. What happens? That this charges, bound charges are here, opposite charges go through my body to earth, and now if I leave it somewhere, put it somewhere, this body becomes a charged body. That is charging by induction. We are studying properties of electric charges. So far we have seen so many properties, including the types of charges, what are the charges, what do they do, and induction. And with the charges, we have also seen how do we classify the material. Okay, today we will study one very special properties of electric charge, that is additivity, but it's a very simple thing. If I am giving charge to this body, then I am again giving charge to this body, what will happen to these two charges? So answer is simply, they can be added, they are added. But in addition, in mathematics, we know that there are different type of addition. One we have is numeric addition, that is only numbers are added, or we can call it arithmetical addition. Okay, then there is one algebraic addition, and there is another one, that is vector addition. You know there is a difference of all the three. If a person has gone 4 km on this side and 3 km on this side, this is the displacement. How much he has moved? We will do arithmetic addition. He has moved 4 plus 3, 7. If we do algebraic addition, then it is 4 minus 3, 1. If we are doing vector addition, then it is root of 4 square plus 3 square, and that is equal to 5. So you see the results are different, and all these three are additions. So charges follow which pattern of the addition? The answer is the charges are scalar quantities. So far we have not discussed it. Remember, charges, electric charge is a scalar quantity. And other thing, it follows algebraic addition laws, like scalars follow algebraic method of addition. Algebraic method of addition. So if a body has got plus 22 charge and we add 10 electron to it, then the total charges it will have is plus 12. This is how the charges are added up. So this is additivity. That means number one, the charges can be added. Number two, what is the method of addition? Algebraic method of addition. So remember, charges can be added together provided they are on one body, and then they are added by algebraic method. Simply according to that, if we are taking a body and removing the charges, if a body has got 22 positive charges and we have taken out 5, so taken out minus 5 charges. So simply it will be like algebraic addition. So it's very simple, the charges follow law of addition. Electric charge, when we give to a material, can we count it? Physics is a knowledge of measurement. Everything can be measured, everything should be measured, and that is physics. If we can't measure it, then we are not fulfilling the full objects of physics. So if we are giving it the charges, like I rub it like this, and now it is lifting the material, it has got charged. Then my question is how much? When we try to answer the question how much, then we come to this property of quantization, that how much is the quantity of charge on a body, how do we calculate it. So its calculation is done with the fact that charge is always carried by transfer of electrons, material, and the number of electrons which are transferred, that will give the charge. So when we are increasing charge, the charge does not increase for all the values. Like if a body has got this much charge, height, and after charging it has got this much charge, this. Then from this point to this point, the charge has not increased this way. Then how it has increased? The answer is charge increases this way. Okay, so what does it mean? This is quantization. Okay. Who carries the charge? Answer, electron carries the charge. One electron carries the charge that we call E. One electron carry the charge E. Then if we are transferring an electron to it, then the charge carried is N into E. This is quantity of charge. Quantity of charge. And this quantity of charge we will give a symbol Q. So Q, quantity of charge, is equal to NE. Now in this we have to understand one thing. N is a whole number. Why it's a whole number? Because electron is smallest entity and it cannot be broken. So if we transfer electron into it, either one electron will come or two electron will come. We cannot make 1.5 electron. we cannot transfer 2.5 electron. It has to be full electron. And once a full electron come, the charge with electron will come is 1.6 into 10 to the power minus 19. If we shift 2 electrons, then it will be 3.2. If we shift 3 electrons, then it will be 4.8, 6.4. So you see, there is a table of 16. If I ask you, this is a body, please give it a charge of 2 into 10 to the power minus 19, 2. Can you give? If you give it 1 electron, 1.6. If you give it 2 electron, it is 3.2. We can never give body a charge of 2. That means the increase of charge on a body is not a continuous quantity. It increases in step. This step is 1.6. Now this has a height of 3.2 and this has a height of 4.8 and this has a height of 6.4. So either you are at this level, this level, this level, this level, that is 3.2, or you are at 4.8. You cannot remain in between. So increase of charge is not a continuous process. Increase of charge is not a continuous process. It's not a continuous process. So it increases in steps, and that we can write the quantization principle. And the quantization principle will be this way. Quantity of charge on a body is integral multiple. This integral is for n, because it is a integral number, it is not a fraction number. On a body is integral multiple of charge on an electron. So Q is equal to NE. This I am making a box. This is quantization principle of electric charge. If somebody asks you, write one line, quantization of charge principle, then you will write this: quantity of charge on a body is integral multiple of charge on an electron. And if somebody asks, what is the reason for this? The reason for this is electron cannot be broken. Electron cannot be broken. So how much will be the shifting of charge? The answer is 1.6 with 1 electron. We cannot make a fraction of it. So this is quantization principle, and this is the first formula. We are now starting. The quantity on any body will be counted by the number of electrons which are shifted, either taken out or taken in. In our nature, in physics, there are so many quantities which are conserved. There are many conservation laws. In mechanics, you have studied conservation of momentum during a process, conservation of energy, conservation of mass. Similarly, in the nature, the total charge of this universe is conserved. That is for the total universe. For any given process, again, the charges are conserved. And what is the general language of a conservation law? It says that we cannot create a new charge. Whatever are the charges in this universe made by the nature, those are the laws. We cannot create it. And similarly, we cannot destroy it from this universe. So the law says we cannot create a charge, we cannot destroy a charge. Then what do? We only transfer charge from one body to the other body. If I rub it like this, I have transferred charge from this cloth to this pen. that I can do. So there will be some charges less and here some charges addition, but the total will remain same. This is conservation law. Okay, so I will write this conservation law, but I will tell you that recently after 1950 there has been certain modifications to this. Okay, we will study that. So first, the conservation of charges in its original form. So I will read it. We cannot destroy or create a charge. The number of charges in the nature are constant and the net charge is 0. That means all the positive charges equal to negative charges. This is a must. Okay, we can only transfer it from one body to the other body. We cannot create, we cannot destroy. Okay, so we see this in every process. All the chemistry you have studied and all the processes in that are giving us these examples. Any process you see, I should say, when we make an ion H, this converts into positive ion and one electron which has got minus. The net charge here was 0 and again it is 0. So in any process the charges will remain same. This is conservation of charges. There is no any process in which the charges are different. We cannot create a charge, we cannot destroy it. Okay. This was the theory, this was the law for many years. But recently there had been certain changes. And the changes are according to Einstein's principle. Material, that is matter, and energy are same. When we compress energy, it becomes matter, and when we open up the matter, it becomes energy, and there is an equivalence between the two, and that equivalence is energy is equal to mc square. So this mass can be converted into this energy, and this energy when compressed converts to mass. E upon c square, this is mass, and mass multiplied by c square, that gives so much of energy. Okay, that is one thing, and on the basis of this we got the principles or explanation of atomic bombs. In atomic bombs and in such reactions we get lot of energy at the cost of material. The material is lost and we get energy. Now, if material is lost and we get energy, there was no problem to the scientist, but there is a problem to the physicist. He says that which material is lost? First, the smallest one is lost, and that smallest one is electron. If an electron is destroyed and it gives energy, no problem, it will give energy. But the thing is, electron is having a charge. When electron is destroyed, then this charge is also destroyed from the nature. So we have just written, we cannot destroy a charge. But in atom bomb we see electron is actually destroyed. If electron is destroyed, then the problem is what happens to the charge in the universe. It was carrying a negative charge. Where do that charge has gone? Should we change our law that it cannot be destroyed? Should we write that it can be destroyed? If it is destroyed, then another important thing is that the net charge of this universe is 0. It will not remain 0. If millions of electrons are destroyed in an atom bomb, then the total charge of this universe will become positive, because so many negatively charged electrons are destroyed, and that is something which is disturbing scientists, that it cannot happen. Like so many processes in radioactivity are taking place in which electrons are destroyed, so this cannot happen. Then what we can do? Then we have to make an explanation, and there was an explanation thought over and made. What was that explanation? The explanation says that there is another particle which so far we did not know, and that particle was then discovered, and that was given the name positron. What is a positron? Positron is opposite to electron. It is a family member of nucleus. Inside the nucleus it is found. Family member of nucleus. Okay, then positron. Its mass is same as electron. Mass same as electron, and it carries a charge, that is plus E is charge on it. But we have never seen it taking participation in any chemical reaction or anything. So we add that it has no independent existence. Independent existence. It is found only inside nucleus, and the moment it comes out, it gets combined with something. So it cannot remain independent. So this positron was defined. Now, what was the work of this positron? The work of this positron comes into action when we see two very famous reactions, that is annihilation and annihilation, and opposite to annihilation is pair production. These are the two reactions which we explain, and that also explain conservation of charges. So now in the next class I will tell you what is annihilation, what is pair production, and how do they take care of our main principle, conservation of charges. Under conservation of charges, today we will study the second part, that what is annihilation process, which gives us a proof of conservation of charges. This annihilation we have observed during atom bomb reaction, that is nuclear fission reaction. In the nuclear fission reaction, there is one electron and one positron. They strike together. One electron, we will write it E, and one positron that is also carrying the charge E but positive. This is electron and this is positron. They strike together. Why do they strike together? Because minus and plus, they always attract each other. So they too attract each other, and they apply force of attraction. Force always create acceleration, and because of acceleration their speed goes on increasing. The force increase to millions times when their distance is so small. So with such a large force, with such a large acceleration, they strike. And what happens with that strike? That strike is so dangerous, so huge, like head-on collision between the two cars at a speed of 200. And that is a very less collision than the collision of this. So if the two cars with 200 speed, 200 plus speed collide head-on, what will happen? You will say each will be distributed into parts, tiny parts. The same thing happens here, and their tiny parts are so small that this material explodes and become energy. After that, when we search, we find there is no electron and there is no positron. Both are destroyed. What they have done? This have annihilated this, this have annihilated this, and this whole process is known as annihilation. What do we get in result? In result of this, we get lot of energy, and that energy is in electromagnetic waveform, and we call them gamma rays. So both are converted, material is converted to energy. Gamma rays. So this is not material, these are rays, and they do not carry charges. No charges. So now what has happened? The charges are destroyed. In this way, our principle, basic principle, that charges cannot be destroyed, we have to amend it. Now charges can be destroyed with one condition, and the condition is that whenever we destroy, it has to be in pair, 1 minus and 1 plus. Only when they two strike together, both will be destroyed, both will annihilate each other. Otherwise, one charge we cannot destroy. And with this, what have we saved? We have saved the principle that the net charge on the universe or the net charge of the nature do not change. Net charge do not change. If there were charges 100 earlier, 100 minus, 100 plus, out of this two annihilate each other. So what we get now? 98 plus and 98 minus, and again this total is 0. This was 0 earlier, this is 0 now. So the net charge is conserved. Net charge is conserved. So this is the process of annihilation, and with this annihilation the charges can be destroyed, but only in pairs, and the net charge is conserved. And now I will write what is annihilation. Okay. Annihilation is a process where one electron and one positron collide, both are destroyed and convert to energy. Net charge remain 0 again. This is annihilation. So after that we will see what is pair production. Opposite to annihilation, in the conservation of charges, you have seen one thing, that when negative and positive charges collide, both are destroyed. That was known as annihilation. Today we will study whether it is possible that there is a opposite action. What is that opposite action? Can we convert energy into material, and a material has got charges? Answer is yes, because whenever we convert to material, the material has to be formed by electrons, and electrons carry charges. So is it really possible to get a charge on a material particle from nowhere? That is, from the energy, from the sun rays which are coming from sun, can we convert it into charge? Earlier our principle was no, it's not possible. But now with the modern physics, we are changing principle and we are supporting it with experiments. So there is a principle of reversibility which says if a process is possible in this direction, this is also possible in this direction. That means if two charges together are destroyed, converted into energy, then energy should be able to convert back to two charges. And recently we have proved it in the lab. What was our experiment? We brought energy waves, energy rays which are most powerful, let us say gamma rays. Now two gamma rays are taken up. Gamma rays. Two gamma rays, they strike a heavy metal like platinum or any such metal. When they strike that metal, they are absorbed in that and their energy is gone. But that energy is so much. What we see in that metal, one electron is created and one positron is created. Yes, these are what? Material. And what is this? Energy. And whenever this energy strike a heavy metal, there is a chance that it will create material, and the very smallest material which is first created is electron and positron. So one electron and positron are created, and that is the charges, carrying the charges. But the point to be noted is that we cannot produce only an electron or only a positron. Whenever there is a production, the production will be the 2 and net charge of nature again remain 0, because yes, minus will increase by 1, plus will increase by 1, net will be again 0. So this has become our law of conservation, that net charge of this nature will always remain 0. We can making collisions, we can make bombs, we can do reactions, and we will lose material in our reactors, nuclear reactors, and the charges are always getting annihilated, destroyed. Similarly, in the universe, we are getting at many occasions the gamma rays which are coming from the universe, sun or from any source. These are getting absorbed and convert into electron plus proton, and this process is known as pair production. So, but one thing is constant, that net charge will always remain 0. So, I will write it down. What is pair production? Okay, I will read it. Pair production is process in which high energy rays strike a heavy metal and a pair of particles are produced which are one electron and one positron, carrying respective charges of minus E and plus E. Therefore, the net charge of the nature remain 0. This is principle of pair production, and this is reaction of pair production. Here, there is another neutrino is produced. This neutrino we will study later, and this is there to balance the magnetic momentum what is carried by the material. So, we will not study this, we will simply study this. We will study in the nuclear reactions, where we will see what happens when this actually takes place. So, in this way we have seen the conservation of charges. This was an old principle, conservation of charges, and pair production, conservation, that is net is 0, we cannot create, we cannot destroy. Then there is pair production, and there is annihilation and pair production. So, the conservation charges now I can write once again, including all the three, and that is the answer when you are asked what is the conservation of charges principle. Okay. So, now our modified conservation principle. The charges cannot be destroyed or created individually, but it can be done in pairs. The net charge of the nature always remain 0. This is now modified law of conservation. We have studied about the forces of attraction and repulsion between the charges. If the charges are similar, there will be repulsion, and if the charges are opposite, there will be attraction. But how much will be this force? This was initially told to us by Coulomb, and it is detailed in the Coulomb's law. Coulomb made a law for this, and on the basis of that we have started our electrostatic forces and all other phenomena which we are going to study. So, what was Coulomb's law, or what is Coulomb's force? Coulomb's force we generally use for the force between two charges, maybe repulsion, maybe attraction. Okay, because Coulomb's law govern it, we call it Coulomb's force. Now, what is Coulomb's law? Coulomb said that if there are two particles having electrical charge, maybe one particle is having charge magnitude q1, there is another particle which is having charge of the magnitude q2, then there will be a force. This will apply force on this, this will apply force on this. So the force applied on this will be in a direction that is along the line joining the two charges. So this is, if it is repulsion, we will show it this way. If it is attraction, then we will show it this way. But in any case, the direction will be along the line. Please remember. The second thing, he said that what should be the magnitude of force? So this force, he said, will be proportionate to the charges q1 and q2. Now, what should be the relation between the two charges? If we are increasing the charges, the force will increase. But how much increase in the charges will bring how much increase in the force? For that, he said the relation is multiplication. That means if this charge is 1 and 1, the force is proportionate to 1, and if this charge we increase 2 times and this charge we increase 3 times, then the force will not be 2 plus 3, 5 times, but force will be 2 multiplied by 3, 6 times. So he found this is not correct, this is correct. So he did not choose plus, he chose multiplication. So q1 multiplied by q2, that is the force. Okay. C is Coulomb's constant, and later in SI system the value was calculated as F is equal to, this C is 9 into 10 to the power 9, Q1 Q2 upon R square. This is the value of Coulomb's constant, and this value is due to this C is affected by the surrounding of these charges, that is medium. So depends on medium. For free space or for air, C has a value 9 into 10 to the power 9, and now we can fix up its unit. Force has a unit of Newton, so this is Newton. R square will be meter square, Coulomb, Coulomb, this will come here. So Coulomb per Coulomb square. So C 9 into 10 to the power 9 Newton meter square per Coulomb square. This is value of Coulomb's constant. Okay, so this was in the free space. If there is a medium, then value of C will change, and that change will be due to a characteristic of the medium. We call that characteristic permittivity, and that we will study in the next lecture. What is permittivity? So this is Coulomb's law. Two things. Number one, the magnitude will be given by this equation and the direction will be along the line, right? So this is Coulomb's law. In the next lecture we will see how this C changes with the medium, and there is a characteristic known as permittivity in the medium which affect this Coulomb's constant or the force between two charges.